All right. Welcome in, everyone. Happy Wednesday. Um, Welcome to my channel. I'm Professor O, and I am going to be hosting another live stream for math engagement, math tutoring. So if you would have a problem that you would like to see me work out, you can post it in the chat. In the meantime, I am going to be working another triangle applications problem. And the reason why is because, well, first of all, I like these kind of problems. Working with force vectors is fun. But I realized yesterday, after I worked the one yesterday, I felt like I just needed some more practice, to be honest. And then I couldn't remember the name for the direction for the compass, and it's bearing. So I'm not gonna, I'll put that back up there. Sometimes I don't have my complete head when I'm getting to host a live stream because of the interface issue I have. So talking to a camera is kind of stale. I prefer to engage with students and answer their questions in the context of the problem. And so it's just a challenge for me up here trying to present and learn how to present to a camera all by myself. Yeah, so I just have to pretend that I have an audience. And if you all have questions, please don't hesitate to ask me. Remember, there are no stupid questions out there, but there are a lot of stupid answers, unfortunately. So, all right, oblique triangle applications. And again, this is a navigation problem. I did spend a little bit of time working with this one before the live stream, just so that I had a little bit, just so I'm a little bit more comfortable. I'm not completely 100% expert on these by any means, but I do know how somehow I'm able to solve them and get the right answers. So I've been trying to, in this old textbook that I have, I've been trying to just work the odd ones, because it doesn't like tell you how to solve it. It just tells you the answer, like to the odds. So if I can get the answer. And then a lot of times I plug these problems into chat, into the Google chat bot, and a lot of times it doesn't even work it correctly. Like I find errors all the time. So anyway, there's never going to be a substitute for a live, real teacher and someone who's willing to give you that time and consideration. There's just never going to be a replacement for it, in my humble opinion. So this one, it says an aviator. I assumed an aviator is someone driving an aircraft, flying an aircraft rather, finds that after traveling 300 miles in an easterly direction, I'm going to try to have this written next time before I start this, just so that you all don't have to, if you do brave my video, you won't have to deal with the squeaky marker. All right, in an easterly direction, and then turns at, it says 250 miles in a southerly direction. He is, this is a very long sentence. He is 400 miles due east of his starting point. It says, find the direction in which he traveled on the first leg of his journey. All right, of his journey. Find the distance, or direction rather. So we have the distances that he traveled, but we're asked to find the direction he traveled on his first leg of his journey. So what I'm going to do is I remember the compass. So we'll put this here. And I do not know why my markers are so squeaky. I need to start being more prepared for this. All right. So I have to learn everything the hard way. So we have north, south, east, west. And we have bearing is either out of the north or it's out of the south. So this is northwest, this is southwest, this is southeast, and this is northeast. And that's essentially how the bearing works. And so what we're going to do is, since we have no idea, we're not going to put it on the compass just yet. What we're going to do is we're going to draw our little airplane. And I reflected on my airplane, and I thought it wasn't that bad, to be honest. But I feel like I could do better. So we're going to draw. See if we got this airplane here. And we got the propeller here. I don't know how many propeller. It looks more like a bird. So I guess I'm not an artist. I better turn in my artist's license. And then when my house windows here. This one is worse than the one yesterday. All right, so we're gonna try to do this one more time. Without even looking at I guess I should just look at the picture. That would help me a lot. Okay, anyway, an airplane. All right, I butchered it. I wish I could just draw a stick airplane. All right, so we're not going to draw the airplane. I give up. But what I do know is I have a starting point and it says I traveled 30 miles in an easterly direction. So we'll just pick a point and we'll draw a vector. And this vector is, I'll have it pointed east for now, but this is, we're going to say this is 300. And then it turns southerly direction. So we'll just call that south. And it only travels, let's see, it travels for 250 miles. So we don't want it to be quite 300, except for it's missing 50. So 250. And then it does tell us the resultant. So it says that we're 400 miles from the original starting point. So we'll say that that's the resultant, 400. So we've got this triangle. It's an oblique triangle. And if we want to know the direction in relationship to the resultant, we'll look for this. I believe it's this angle for our first leg to find out where it is, where we're going to put it on the map, on the compass. So we'll draw our Cartesian coordinate system because we're going to eventually put this, we want to put it on the Cartesian coordinate system, but we don't necessarily know that original direction, the bearing, essentially, from the north. We know it's an easterly direction. And if he's headed south, then he was in a northern orientation. So he was north of some point south that he ended up. So what we're going to do is we're going to draw our triangle similar, very similarly to the one that we have. We'll call that angle A. This will be C. This will be B. And then we need little a, little c, and little b. And when you have a triangle and you only know the side lengths, really, it's an oblique triangle. You're going to have to use law of cosines. Like, there's nothing else that you can really do. You might be able to use half angles. But as far as either for oblique triangles, law of cosines, I think it's probably the best bet. So we have some values here. So we're going to make a list. So we'll say little a, we only know the side lengths. So we only know little a, little b, little c. And this will be our angle alpha. So we'll call a 300. That is the first leg of his journey, was the 300 force vector. And then we'll say B was the 250. I always like the longest leg to be my hypotenuse, to be C. I don't think that that's mandatory, but for some reason in my head, that's what works. So we got 400. And we've got big C. Actually, this case, we're going to be looking for the big A. And that is what we're asked to find, is this, what direction was I headed originally? Before I took that turn south. Okay, so before I headed that direction, if I was going to get my actual bearing, my direction, I would use that angle right there, call it gamma. And this is just me thinking about these vectors and how this all works. So what we're going to do is we're going to set up our law of cosines in relationship to our angle A. And I can go ahead and I can put that, let's put it over here. So I have plenty of room. So it's going to be a squared. And that equals b squared plus c squared minus 2 times bc cosine a. And then I've got my values. I'm just going to plug in. So I've got 300 squared equals b squared 250 squared plus 400 squared. And that's minus 2 times 250 times 400. And this is all times the cosine of a. Again, we're solving this very similar to how I solved it yesterday. So now I need my calculator. And we've got 300 squared. That's 90,000. And then we've got 250 squared is 62,500. And then we've got 400 squared is 160,000. And then we've got 2 times 250 times 400, and that is 200,000. So minus 200,000 cosine of a. All right, so now we're going to combine like terms, and because we're going to solve for cosine a, so we've got to combine these constants, these three. So I'm going to begin by adding these two, and then I'm going to subtract it from 90,000. So we've got 160,000 plus 62,500. And I'm getting 222,500. Minus 200,000 times the cosine of a. And that equals 90,000. All right. So now minus 90,000. So we're going to subtract this quantity 222,500 from both sides. And this is a larger number, so it is going to result in a negative here. So I'm getting negative 132,500, and that equals negative 200,000. Is there really 5? I want to make sure there's really 5. That is 200,000. I'm pretty sure it is, but okay. All right. So that is times the cosine of a. And now I'm going to divide off negative 200,000 from both sides. And at two negatives, when you divide two negatives, you get a positive. So we're going to end up back in positive land. And 132,500 divided by 200,000 is 0.6625. 0.6625 equals cosine A. So now all we have to do to solve for the angle A is that we're going to use that arc cosine function again. So remembering inverses to solve. So we have cosine A, using that reflexive property of mathematics. I have this equal this, so I can just switch the order. It's 0.6625. And then performing that arc cosine, you get arc cosine of this value, 0.6625. And then that's going to equal A. So A is approximately x. Okay, so I'm getting 48.50918314. So we're just going to say 48.5. Also, what we're doing, let's go ahead and put it up here. If I was traveling, let's see, 48. First of all, cosine, you have to remember, cosine is positive in the first quadrant and the fourth quadrant. They're both positive, and then we've got positive, negative here in the fourth quadrant. So we've got to be either here or here. And it said we were moving in an easterly direction. And that angle that I was moving at, this angle right here, it's giving us alpha is 48. Let me see if it'll give me DMS here. All right, 48 degrees in 30 minutes. So we've got 48 degrees, 30 minutes. And 33.059 seconds. So it's saying that that's where I was. That's this angle right here. So we've got an angle here. It's giving us the reference angle. So if I drew a 48-degree angle, let's see, halfway is about 45, so it's slightly, say it's slightly, let's see, 45, 45. It's going to put the direction, because remember, you're going to be out of the north for your bearing. So if I drew that angle in there, like in here, and there's a mistake in here, because when I worked it earlier, I got 30 something. But what it's telling you is it's going to give you the cosine of this angle alpha, but our bearing here is going to be, well, they like to use phi for bearing and spherical coordinates. So this is the actual bearing. So it's saying the angle is 48. How long? We're only 24 minutes. Let me see if I can find the error real quick so they can. I've got my paper I worked out. Look at it. I got 0.7825 for cosine. 0.7825 store for X. Yeah, it's going to be, all right, so I said A squared did I calculate A squared wrong? Okay, so A, what is that? 300 squared that's 90,000. Got A to be 250. Alpha A is 250. Hang on, I found it. All right. So I got ahead of myself here. And if you notice right here in my logic here, the angle opposite A is 250, not 300. So I have to switch those two values, which matters. So that's why. Okay. So we've got 250, and then B is going to be 300. All right. So then I don't know if y'all want to go through this one more time, but whenever you plug in here, you're just going to switch those values. So, all right. One more time with the law of cosines. All right, so we're close, but we weren't exact. So that's going to be, that'll be 250 squared equals 300 squared plus 400 squared minus 2 times 300 times 400, and then that's going to give you the cosine of A. All right, so get that out of the way. One more time. 250 squared. Maybe after this, I'll move on and find another subject. Like, I was thinking about trig identities. We'll get into trig. Mathematics is such a broad variety of math and different kinds of maths. You can pretty much, I could host a live stream for the rest of eternity and still not cover all of the mathematics. And I mean, I would have to learn along the way because I definitely don't know that much. Okay. So 400 squared plus 160. I might need to start hosting live streams in the morning. The morning is the best time to do math, to be honest. And that's minus 240,000. Look at me. 240,000. I ran out of room, so I'm just going to put it on the bottom, cosine A. And then we're going to add these, subtract from this. $250. I know that the right answer, because I have it in the back of the book, so I know what it is, and it wasn't 48. It was close, but not quite. So let's see if we can get a better answer. 625, 00, and that's minus 240,000. Again, cosine, law cosines, you end up having to deal with very large numbers. So it's just challenging sometimes keeping track of all the significant digits. But we're going to end up with 250,000 subtracted from 62.5. This is a bigger number. It's going to lead to negative. So that's 187,500. And that equals negative 240,000 times the cosine of A. And then we're going to divide off negative 240,000 from both sides. Get this problem solved. All right. So we've got 187,500 divided by 240,000. And yes, as I suspected, it's a positive 0.78125. And that equals the cosine of A. Now we're just going to use that arc cosine, and another way to represent it is you can just say cosine inverse, and then you put that in there in the argument, 78125, and that equals A. So A is approximately it says 38.62, and that this is more correct. 38.62483,287. And so now what we're going to do is we're going to subtract this one, 38. Here, we'll do DMS to get exact. It says 38 degrees, 37 minutes, and 29.398 seconds. So what we have to do is we have to subtract from 90, because we've got 90 degrees here. So to find the actual bearing, which is the direction, is giving me 51 degrees. Let me get DMS, hold on, 4. All right, so it's giving me 51 degrees. So the first leg of his journey, he was traveling in an easterly direction at 50 at a bearing of 51 degrees, 22 minutes, and 30.602 seconds to answer the question. And I feel a little bit more confident with these now. After that, I couldn't even remember the word bearing yesterday, so I know that it's it's not getting a whole lot of use. It's not the best, most interesting subject, but I think that it's important to know how these force vectors work and being able to use them to solve applications. So hopefully it's helped somebody out there, at least one person, then it's worth it. And for me, I'm getting practice. I'm getting more comfortable in working with the camera. So again, hope everybody's doing well. And yeah, hopefully this is encouraging someone or multiple people to do the math. And it would be exciting to have, be able to do math in the community together. But I will manage my expectations, and I will just show back up tomorrow and hang out and try to figure out something else to present. If you have any suggestions on anything that you would want to see presented, please let me know. You can post in the chat, or you can give me a message or whatever. I'm fine with that. I am trying to, again, like, learn how to um, be myself in front of the camera. I don't want to appear stale, but I don't also want to, appear unprofessional. So me just working on it. And thank you so much for watching my video and listening to me ramble on about absolutely nothing. Um, but anyways, again, maybe I'll try harder not to do that in the future. So I managed to make it 35 minutes. And since I don't have really anything in the chat, I'm going to go ahead and end my stream for now. And yeah, I'll be back again, same time, same place. 6 and 7 p.m. Central Time right now, and until further notice. And yeah, I'll just see you again tomorrow. I'll say bye for now.